Hi, and welcome to this quick introduction to the chemistry drawing questions that you'll find in the Chem 1011 and Chem 1051 practicals. In these practicals, you'll encounter real-life chemistry, such as dissolving salt in water. But a big question here is, why can't you actually see the salt once it's dissolved in the water? The chemistry drawing questions can help us actually describe what's going on here. They really help us to bring together the concepts we've learned in the lectures with what we're doing in the experiments. For example, this animation shows that when we dissolve sodium chloride in water, there's actually way more water molecules than the number of sodium and chloride ions that there are. So let's have a look at how to figure out one of these drawing questions. The question says that table salt, which is sodium chloride solid, is added from a salt shaker into a glass of water to form aqueous sodium chloride. Part A asks us to sketch an atomic scale depiction of the sodium chloride in the salt shaker. So that is solid. Let's just draw our salt shaker. Now, we know that sodium chloride is an ionic compound, and we can see that it's solid. So it's going to have a lattice structure with alternating sodium and chloride ions. Now, this is what it will look like. And see, it's like a checkerboard. We've got the sodium alternating with the chloride because those opposite charges attract each other. And you would continue this until we've got enough that we can see that there was a solid clump in the salt shaker. Next, we need to sketch an atomic scale depiction of aqueous sodium chloride. So now it's been placed in the water, it's dissociated, and we can't actually see it in the water anymore. So if this is our glass, let's start with drawing a sodium ion and a chloride ion. Now for every sodium there's one chloride because we can see that here. So let's just draw one of each. Now, as we saw in the visualization earlier, there's heaps more water than any of the sodium or chloride. But how do we draw water? Well, we know that due to its two lone pairs on the oxygen, water has a bent geometry. Also, because oxygen is more electronegative than hydrogen, there will be a partial negative charge on the oxygen and partial positive charges on the hydrogens. This negative side will point towards any positive ions, and this positive side will point towards any negative ions because opposite charges attract. Let's draw that in. And we'll just draw some dotted lines between these charges to show the attraction. We'll also draw some more water in there just to show our demonstrator that we know that there's heaps more water than the ions. Now these questions will often ask you to show the correct scale, shape, and orientation of what you're drawing. Scale means the relative atomic sizes are correct, and I've done that. Shape means that we've drawn molecular geometries correctly, and we have done that too, for example, the bent shape of water and the correct lattice structure in part A. Orientation means that the water molecules should be oriented so the correct side of its dipole is facing any ions, and we've done that too.